You know, every single time you power up your phone, or even just walk out of a dead zone, something incredible happens. An invisible security check, a digital handshake, takes place in just a fraction of a second. It's the critical barrier standing between you and a secure connection. But how on earth does it actually work? Well, let's break it down.
So it really all comes down to these two big questions, right? It's all about trust. Your phone has to prove its identity to the network, for sure. But, and this is just as important, the network has to prove it's the real deal, not some fake, malicious tower trying to listen in. So how do they establish this two-way trust?
Well, the answer is a really sophisticated protocol. It's basically a highly specific, very strict set of rules for this digital handshake. It's the invisible guardian of your connection to the entire LTE world.
Yeah, it's called EPS-AKA. And I know, that sounds super technical, but at its heart, it's really just a challenge-response system. Think of it like a secret knock. The network gives your phone a challenge, a question that only your specific phone could possibly answer correctly. And in that same process, they both agree on the secret keys they're going to use to encrypt everything you do.
Okay, so who's actually involved in this secret knock? To really get what's going on, we need to meet the security team, the three key players that make this whole invisible handshake happen.
First up, you've got the UE, which stands for User Equipment. That's just the fancy engineering term for your phone and its SIM card. Then there's the MME, which you can kind of think of as the network's brain or its main control center. And finally, you have the HSS, the Home Subscriber Server. This is like a high-security digital vault that holds all the secret keys for every subscriber.
And this right here, this is the most crucial part of the whole setup. The entire system is built on a shared secret key called KEY. A unique copy of this key is burned securely right into your SIM card, and the network keeps its copy locked away in that HSS vault. And here's the golden rule. This key is never, ever sent over the air. Its power comes from the fact that both sides have it, but nobody else can ever see it.
Okay, so we've met the team and we know about their shared secret. Now, let's actually walk through how they use it. Here's the step-by-step journey of that challenge response process we talked about.
All right, here's the 10,000-foot view. Your phone pops up and says, "Hey, I'm here." The network's brain, the MME, then pings the HSS vault and says, "Hey, I need a security test for this guy." The HSS generates that test, the MME sends just a piece of it, the challenge, to your phone does some quick crypto math to create a response and sends it back. Finally, the MME checks the answer. If it matches, you're in.
Now that test that the HSS vault cooks up, it has a special name. It's called the authentication vector, or AV for short. It's this tiny but incredibly powerful package that contains 4 critical pieces of data that make this entire handshake possible. So, let's take a look at what's inside.
Okay, let's unpack this little bundle of security. Inside the AV, we have RAND, which is just a random number. That's the challenge, the question. Then there's XRES, which stands for expected response. That's the answer to the question, which the network keeps to itself for now. Next up, AUTN, and this is a big one. It's a token that proves a network is authentic. And finally, KASME. That's the master key for the entire session, just waiting to be activated.
So here's the crucial move. The network sends 2 of those things to your phone, the random challenge, RAND, and the network's proof of identity, AUTN. It holds back the correct answer, the XRES. It's kind of like a teacher giving you a quiz question but keeping the answer key safely locked in their desk.
But hang on a second. So far, this just sounds like the network is testing the phone. What about the other way around? This, my friends, is where the process gets really, really clever.
I mean, how does your phone know it isn't talking to a fake cell tower, an imposter set up by an attacker to intercept your data? This is honestly one of the most important security upgrades in the jump to LTE.
Well, the magic is all in that AUTN token we just mentioned. Using its own copy of that secret key, KI, your phone inspects the AUTN. It's basically a cryptographic signature that proves that whoever sent it also has the secret key, KI. If that signature checks out, your phone knows the network is legit. If it doesn't, the phone just drops the connection, no questions asked. That's what we call mutual authentication.
So, at this point, both sides trust each other. The handshake has been a success. But we're not quite done yet. The final and absolutely critical step is to use that newly established trust to forge the secure keys for your actual conversation.
Remember that master key, KSME, from the authentication vector?
Well, now that the handshake is complete, that key is activated on both your phone and on the network. Think of it as the seed from which all the other security keys for this specific session are about to grow.
And this shows off just a brilliant security principle. You never, ever use your master key for everyday tasks. Instead, that master key, EPS-AKA, is used to generate a whole family of disposable single-purpose keys. You get one for the connection to the cell tower itself, others for encrypting all the background control signals, and totally separate keys again for your actual data, like your voice calls or web browsing. It's like having a master key that can create a brand new, unique key for every single door you need to open.
You know, to really appreciate just how robust this system is, it really helps to look back and see how far we've come from the older days of mobile tech.
The real leap forward becomes crystal clear when you put this up against older 2G or GSM technology. Back then, it was totally a one-way street. The network tested the phone, but the phone just blindly trusted any tower it connected to. This left it wide open to imposter attacks. But with LTE's mutual authentication, it completely changes the game. And then you add in much stronger, longer keys and a completely fresh set for every single session, and yeah, the difference is just night and day.
So let's just recap the big wins here. You've got mutual authentication, which slams the door on fake towers. You've got key freshness, which means even if one session was somehow compromised, it has zero effect on the next one. There's replay protection, so an attacker can't just record an old challenge and try to use it again. And finally, key separation, which neatly compartmentalizes all the different security tasks.
This all comes down to one fundamental principle that is just baked right into the protocol's DNA. If any single step of this intricate dance fails, if the phone's response is wrong or the network's proof is invalid, the connection is just dropped instantly. There's no fallback, no trying again. The system always prioritizes security above all else.
The EPS-AKA protocol really is the heart of LTE security. It's a fortress built on secrets, challenges, and mutual trust. But you know, no fortress is ever perfect, right? Which leaves us with one last nagging question. With a system this strong, what potential cracks could possibly still exist in these walls? Well, that's a topic for our next explainer.